Okay. Oh, measurement. We're looking at the sine and cosine rules now. We're going to talk about trigonometry. This is now reflecting on before. I would have expected that most people would have said trig was their hardest, but it actually usually doesn't go that way. I feel like it's usually more split evenly. I think trig's the hardest personally, but it's only because it's something that I just always have trouble with. Okay, so cast your mind back to year 11. We learnt about sin, cos, and tan. We learnt about hypotenuse, opposite, and adjacent. We learnt about SOHCAHTOA. So I want you to think SOHCAHTOA as existing back in year 11. We don't want to think about that today. We're thinking about year 12, which is the sine rule and the cosine rule. So the sine rule is one way in which we find missing sides and missing angles and triangles when they're not right angled. So we're all in the world of non-right angled trig. All of this stuff you learn in year 11 only applies to right angled trig. All the stuff we're learning today applies to non-right angled trig. So to find a missing side using the sine rule, you need to have two angles and one side already. So first let's talk about how we even label our triangles. All of our triangles are just labeled by letters, big letters and little letters. We use capital letter A, B, and C to highlight or to label our angles. Angle A, angle B, angle C. To label our sides, we label the opposite side to the angle we just labeled with the lowercase. So if this is angle C in this corner, we label this side C, lowercase. If this was angle B down here, we label this side angle B, side B, and if this was angle A up here, this is now side A down the bottom. You can label them all the sides whatever you want, as long as it's A, B, and C. It doesn't matter which one's A, B, and C. There's no rhyme or reason. A, B, C in any order. The sine rule, critically, should have pointed that out, is A over sine A equals B over sine B equals C over sine C. It is on your reference sheet in the bottom left-hand corner. You get 4 things for trig: area of a triangle, sine rule, and then the 2 cosine rules. All right, let's look at some examples. This is a non-right angled triangle. We have been given 2 sides and an angle, and we're being asked to work out the missing side. We're asked to work out side B here. So, sine A equals A over sine A equals B over sine B equals C over sine C. Whatever we're looking for is the piece of information that we place on the top of our equation. So if we're looking for a side, we put our sides, A, B, and C. That's where we go A over sine A. If we're looking for an angle, we would do sine A over A. The sine is always attached to the angle. You don't switch it so it's sine side. So we only ever need 2 parts of the equation. We don't need to do all 3. We can do it like this. We can do it like this. We just need 2 parts. We're going to do B, which is the side we're looking for, over sine 34, it's the angle opposite, equals 13, which is the side we already have, over sine 68. So essentially, this equation compares a ratio between an existing side and angle to determine what the missing side must be to the angle that we have. Once we pop all of that in, the simplest way to think about this is simply cross multiply. Just move sine 34 to the top. So we go B over sine 34 equals 13 over sine 68. We simply move sine 34 to the top and we do 13 times sine 34 equals sine 68. And let me confirm with you that that is the correct answer in my actual calculator. It's very important you pop the fraction in. If you don't, it will be wrong. Sine 34, and always put brackets on the end of your sine. Sine 68. 7.8. Yeah, that's still the correct answer to 1 decimal place. You could also write 7.84 if it was not. Okay, you can also use the sine rule to find a missing angle. You simply flip the equation. So now sine A is on the top. So let's say we're looking for theta in this equation. We have 2 sides and we have 1 angle. Importantly, the angles and sides must correspond. So see how this is C, angle C and side C, and this is A, angle A and side A. Okay, so once we get our missing angle, we want to find A. We're going to pop it over the side we have, which is 7.1, equals sine 30, a angle we already have, over a side we already have, 4.8. Again, critically, they must be related to one another. Sine A equals 7.1 times sine 30. Remember our cross multiplication. Move this to the top. Sine 30 times 7.1 over 4.8. Now, very, 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 very important. Please listen to me when I say this. If you are finding an angle, you have to hit shift sine so that your sine, I don't know if you can see that, is a -1. If you do not do that when you're finding an angle, it is going to be incorrect. You are not going to get the mark. Boo. Always do inverse sine. This is what we call this. Inverse sine or sine -1, whatever you can use to remember. Sine -1, all of this goes in brackets, which your calculator automatically does. If you hit shift sine, you see that the brackets, I don't know if you can see that, open up, and they automatically become sine -1 bracket. Once you pop all of that in, we get 48 degrees. Now remember, when you find an answer, hit this button on your calculator with the little bubbles on it to get the actual degree. Okay, if you cannot use the sine rule, this is where the cosine rule comes in. So very important, sine rule we're using to find missing angles and missing sides. Cosine rule we could use to find the exact same things. We can still find missing angles and missing sides. Okay, so the cosine rule to find a missing side is c squared equals a squared plus b squared minus 2 times a times b times cos c. One more time. C squared equals a squared plus b squared minus 2ab cos c. This is on your reference sheet in the bottom left-hand corner. If you need to find something using this rule, this involves all 3 sides and 1 angle. You're going to have 2 sides and 1 angle already. Importantly, you must have 2 sides A and B and angle C, which is going to be the angle between them. Because if this was side C, this is going to be angle C. See how that's cos C? Because you're looking for this side. So if we had a triangle and this was A, this was B, and this was C, and you were looking for C, and you had this angle and you had this angle, you can't look for C using the cosine rule because you need this angle to find it. That's why it's very important that you check what angles and sides you have. In that case, you would use the sine rule. All right, let's have a look at an example. C squared equals a squared plus b squared minus 2ab times cos c. In this equation, or in this question, we're being asked to find this side, x, which is really side C. But we're going to represent it using x squared. So we have a squared, which was this side, 12.5, plus 9.8 squared, minus 2 times a times b, times cos 23. This is the angle opposite the side we're looking for. Angle C. Once we do all of that, we're going to get a nice big number. C squared equals 26.766. We then go square root 0.766. Square root it, 5.2. It really is 5.17, but we're going to round to 1 decimal place and say 5.2. Okay, so like the sine rule, we also rearrange the cosine rule to find an angle. This is also on your formula sheet. You do not need to remember how to change it. It is the last thing on the left-hand side. Cos C equals a squared plus b squared minus c squared over 2ab. One more time. Cos C equals a squared plus b squared minus c squared over 2ab. So if we're looking for the angle in here, angle theta, we're going to find, or check all of our sides first. We have all of them. We don't need any other angles, but the order is important. A squared, which is this side, 8.4, plus b squared, 4.7, minus 6.8 squared. That's the other side. Over 2 times 8.4 times 4.7. Once we do all of that, we need to put it into inverse cos because why? I'm going to pretend you're saying back to me. Correct. We're looking for an angle. You need to do inverse cos or inverse sine whenever you're looking for an angle. Once we do all of that, I will tell you the answer as it's not on the screen. Hold on 1 minute. Always important, put the bracket at the end, otherwise it'll give you a math error. And that is 54 degrees. Oh, let me check my degree button. Hold on. Yeah, 54 degrees. Okay, we're going to answer these ones together as well. They're definitely good ones to come back to. Okay, let's have a look. Find side X. This is really side C. We can think of it as side C. Let's just pretend these are all side C. All right, c squared equals a squared plus b squared minus 2ab cos c. C squared equals 12 squared plus 7 squared. We need our two opposite sides. A squared, which is this side, plus b squared, which is this side. Minus 2 bracket 12 bracket 7 times cos 78. Important. When you are finding an angle, you use inverse. When you are writing an angle, you don't need to use inverse. So see how this is just cos 78, or in the sine rule, it's just sine 78. You only use the inverse if you are actively using that function to find the angle, not simply writing the angle out. Once we've done all of that, our answer is 158.071, and we pop that into our square root because we can see that our formula for the cosine rule is starting with c squared. Once we do that, we get C, or side C, equals 12.6. And we want to write kilometers as well. All right, find the missing angle. This is a sine rule question. Sine A equals sine A over A equals sine B over B. We're going to find this angle here, which is angle A, opposite side A. Let's label all of our sides just to help us. We've got a full piece of information here, 34 degrees and 7.6 millimeters. Okay, we're going to pop in sine A, which is what we're looking for, over its side, which is 13, equals sine 34, which is the angle we have, over this other corresponding side we have, which is 7.6. We're then going to move the 13 to the top. 13 times sine 34 over 7.6 is going to equal to, once we pop in our inverse sine, 73 degrees to the nearest degree. Okay, this is a question that we're going to work through together. From point S, which is 1.8 meters above the ground, a pulley at P is used to lift a flat object, F. The lengths SP and PF are 5.4 meters and 2.1 meters respectively. The angle PSC is 108 degrees. Okay, so let's have a think here. Show that the length PC is 6.197 meters, correct to 3 decimal places. Calculate H, the height of the object above the ground. We have a 1-mark question and a 4-mark question. Let's just have a look at our question first. We have a triangle in here. We want to find the height of PC. We're trying to find this length here, PC. So essentially, the first thing I would do is think of this as its own triangle. This is 108 degrees. This is 1.8 meters. This is 5.4 meters. And that is all the information I have. I now need to find, let's call this side C. So this is angle C. Let's call this angle A, side A, angle B, and side B. How am I going to find my missing angle? I am going to use the cosine rule for this one. I've got them on my formula sheet. So the cosine rule for finding a side is, remember, c squared. So let's just call PCC for now. C squared equals A squared plus B squared. A squared is going to be 1.8 squared. B squared is going to be 5.4 squared. Minus 2 times A, which was 1.8, times B, which is 5.4, times cos C. Cos C is my angle 108. Once I pop all of that into my calculator, which I'll do now, we need to square root it all once we're done. So 1.8 squared plus 5.4 squared minus 2 times 1.8 times 5.4 times cos 108. Close brackets. Remember, we don't need to inverse it. We get a big number. We get 38.407. I'm now going to square root 38.407, and I get 6.197. We want to go to the nearest 3 decimal places. 6.197 meters. And now we need to calculate h, the height of the object above the ground. This is h. So how are we going to do that? We first want to find, if we think about this logically, what we're actually even looking for here. So we have a triangle that we can pull out here, which we can now draw over here. We have this side, which was, we've just found 6.197. We know that this is 2.1. This is h. This is what we're looking for. We know that this is a right angle. And we don't really know much more than that. So let's go back to our original triangle. What else could we potentially work out from this? Because we're not dealing with right angled, we're dealing with non-right angled. So what are we dealing with over here that we can use to find our edge? Okay, so if we start with our old triangle, going back to here, we can use this information to find the angle that is in this corner. So really, let's call this angle B. So let's go through and find angle B. We're looking for angle B, which is sine B over, what's our side, 5.4. And what's information we already have? Sine 108 over the side we just found, which is 6.197. Once we do all of that, and we rearrange our formula, let me figure that out for you. We get 0.8287, which is really once we angle 55 degrees, 58 minutes. So 55 degrees, 58 minutes is this angle in here. Now that we have that, we can subtract 55 degrees, 58 minutes from 90 to find out what this angle over here is. Now, because we figured out that this here is 55 degrees, 58 minutes, if we subtract that from 90, we find that this angle is 34.2 degrees. So work through it methodically. We now know that that is 34.2 degrees. What can we do from there? We can now find the height of the object above the ground by going back to our sine rule and by applying our traditional sine application from right-angled trig. So we know that it's this angle we're looking for. Oh, sorry, not this angle. We're looking for this side. So let's do sine. Let's label. We've got hypotenuse. This is going to be the smaller side. So we've got adjacent and we've got opposite. We have information for, let's see. Yeah, opposite and hypotenuse. So we're going to do sine because we have we're looking for our opposite, and we have our hypotenuse. We're looking for the total opposite so we can find h. Because we have 2.1, we're looking for this part. So what we're going to do in there is do sine 34.2 degrees, and then we want our opposite over our adjacent, which is going to be 2.1 plus h over our hypotenuse, 6.197. And once we do that, we work out that, so we flip it all around, and we should get 6.197 times sine 34.2 degrees, and that's going to equal 2.1 plus h. So we know, once you do all of that, I'm just skipping ahead so you don't have to see me write all the working down, 3.468 equals 2.1 plus h. So all we have to do is go 3.468 minus 2.1, and we get h is 1.368. Thank you for sticking by me with how long that took. Hold on, it's really 1.4. This is just my way of illustrating to you that these questions require long bits of working out at certain points. So that is where we end up. I'm going to give you a second to look at that and pick apart any part that you didn't understand. Okay, great. Let's move on to bearings. I hate bearings. Bearings are definitely not my favorite part of the syllabus whatsoever. I think they suck, but we have to learn about them. They're the direction of one object from another. There are two types of bearings. We have compass bearings and we have true bearings. Today we're specifically going to talk about how we use true bearings and then how they appear in questions. So true bearings, in simplest form, are measuring the way in which an angle moves clockwise from north. They're always 3 digits. We have an example here. First one, we move from north all the way around clockwise, 3 o'clock, 6 o'clock, 9 o'clock, say that's 10 o'clock. We're 31 degrees from the west line, so we're going to add, it's important you memorize these numbers, 90, 180, 270. If we add 31 to 270, we have a true bearing of 301 degrees true. You always need to write 301 or the number true, and there always needs to be 3 numbers. Let's see how that works with this one. This one, north clockwise, is only 56 degrees, but we have to write 0 beforehand, 56 degrees true. All right, alternate angles. This is important in bearings. They form a Z shape with the transversal. This is the line running between the parallel lines. See how these lines are parallel? This is the transversal. See how this forms a Z. These angles here are the same size. Corresponding angles are on the same side of the transversal, but below each of the parallel lines. They are the same size as well. Co-interior, so co-inhabiting the same interior, both on the same side of the transversal and inside. They're in the same room. They are supplementary, so they're going to add to 180. See how this one is smaller than 90 and this one's bigger? They're going to add to 180. All right, let's have a look at an example. A plane flies for 250 kilometers on a bearing of 48 degrees true, then turns and continues for 385 kilometers on a bearing of 145 degrees true. How far is the plane from its starting point? So we're going to work through this with some drawings. We're first going to pop our north line on. Then you're going to draw in a 250 kilometer line, not really 250, you know what I mean, with a bearing of 48 degrees true. So try and be accurate. You don't need a compass, but try and be somewhat accurate. Draw on another north line. Then we're going to draw in our 385 kilometer, 145 degree turn. That has now created a triangle. These steps that I've just indicated here are something that a lot of students miss. Very, very, very important. The whole point of these questions is turning them into triangles. Once we've done that, we have a 250 kilometer line, a 385 kilometer line. That's the angle we're looking for. We're looking for theta. How far is the plane from its starting point? This is the line we're actually looking for, but step number 1, we need to figure out our angles. So we have co-interior angles here. think of our parallel lines. We have two angles existing here. So 180 minus 48, we know that this angle here is 132. Step 2, we now have this circle here. We have 132, 145, and we have something existing in here, which is theta. We minus 132 and 145 from 360, we get 39. So we now know that that is what our triangle looks like, 39 degrees internally. We can now use the cosine rule if we go back to our angle that we just learnt, and I'll write it quickly for you. Cos C equals a squared plus b squared minus c squared over 2ab. And we end up with 247.23 kilometers. All right, another question. Points A, B, and C are 3 ships. The bearing of A from B is 59 degrees true. The bearing of C from A is 167 degrees true. If AB is 8 kilometers and AC is 6 kilometers, what is the bearing of B from C? First thing, pop our north line on. Next, we're drawing our 59 degree true line from B to A. A from B indicates B to A. Read it always from is the starting point. The second letter is the starting point, not the end point. A from B. Once we've drawn that line on, we then draw on our 167 degree turn, which is 6 kilometers AC. We pop a north line on. Guess what the next step is? Make it a triangle. Once we've done that, we now have identified the bearing we're looking for. The bearing of B from C is starting at C and going clockwise until you hit the B line, which is this line here. We now need to work that out. So fill in all the angles you can. Let's have a look. We can use our co-interior. 59 plus 121 must equal 180. Therefore, we have both angles on the side of our north line there, which means we can subtract 167 and 121 from 360, and we get 72 degrees. We can then pop on 13 degrees for the same reason over here. 167 plus 13 is 180. Now we use our cosine rule to find 8.39 kilometers to 2 decimal places, which is this line here, by using our cosine rule. And remember, that is the side rule. So c squared equals a squared plus b squared minus 2ab cos c. And then we have the sine rule or the cosine rule. Either of them work because we have so much information to find this internal angle, which is 64 degrees, like that. And then we can find the bearing, which is 283 degrees once we subtract 64 from 360. That is how you would do this question. I know it's quite hard to understand when I'm just reading out the working out to you, but in practice, hopefully those steps help you. All right, here's a practice question. Anthony is standing 145 meters due east of the hole at a golf course. On his first shot, Anthony hits the ball 94 meters, but not at the correct angle. On his second shot, he hits the ball 60 meters and gets it in the hole. On what bearing did he hit his first stroke? So we've drawn out our beautiful triangle there. We have Anthony, we have the 94 meter first shot, we have the 60 meter second shot, and we have the hole, and then we know that we're 145 meters from the hole when we first start. We want to find the bearing he hit his first stroke at, which is really this bearing here. So this here, we're looking for this angle. So we don't even have any of the interior angles, and we need to find an exterior. Let's slow down. We can use the cosine rule here to find an interior angle because we have all 3 of our sides. So let's label our sides first. We're going to find cos C. So let's find this angle because we want this internal angle here. So we're going to label this side C. This is going to be side A, which makes this angle A, and this is angle B and side B. Okay, so cosine rule, we're going to do cos C, which is the angle we're looking for here, equals a squared, which is 94 meters squared, plus 145 meters squared, minus 60 meters squared. And we do 2 times A times B. So 2 times 94 times 145. Once you put all that into our calculator, we get, give me a second, because we have to pop it into cos C. We have to do -1 as well, brackets, fraction 94 squared plus 145 squared minus 60 squared over 2 times 94 times 145. Make sure you close your brackets. 15.559. I'm going to hit my bubble button. It's 15 degrees. So I know that that's 15 degrees. We now need to do 90, which is this here, minus that 15 degrees equals, and we're going to get something like 75 or 74, depending on what point you use, degrees, and we can see that there. It's 74.44 degrees true. Remember, we're looking for this angle, which is our bearing of our shot, and we need to represent it as 074 degrees true.